So, hey everyone, I'm from Riga, and basically I'll tell you how we do things there, and what is our digital twin strategy for us, and how we are planning to actually develop this kind of capability in our municipality. So, I'll basically tell you a little intro about us, about how essentially our data analytics team works in Riga City Council. I'll tell you about our digital data analytics and digital twin strategies. We'll then go over some terminology, which is going to be very similar to what Markus already showed us. And then we'll see what kind of the roadmap which we're planning and how we're going to basically develop this whole thing in our city. So, small introduction about me. That's me in a library, in a university library with a book which gave me nightmares for more than 2 years and a little bit of depression. So my academic background is originally in economics and finance, so it ironically happened that I failed econometrics course 3 times in a row, so I had to go back and study it more and more. And this is, I think, one of the reasons why I pivoted and started working in the data field. And so far I have worked in multiple tech startups in various data analytics positions, starting from data analysis, ending with data science and data engineering. And currently I'm the head of data of Riga City Council, and I'm working as a part of Riga Digital Agency, which was established a little bit more than a year ago. And we are essentially Riga IT department, which is providing IT and data services to the whole municipality. So right now here I have traveled to Tallinn here with my very wonderful team, which is sitting somewhere there in the middle. And we are an internal data analytics team as a part of Riga City Municipality, also basically known as Data Center of Excellence. And we are a team of data analysts, data engineers, and data scientists. So it's a mix of all kinds of data technical expertise. And we're probably one of the first fully technical sort of IT data teams in the municipality. And what we do is that essentially we provide all of the following data analytics related services to our city departments, city agencies, and various other stakeholders inside our municipality. As you know, our municipality is pretty large. It's more than 5,000 employees, so there's a lot of data services that we have to provide to our other colleagues. And we basically do all of these things that a regular private sector data analytics team would do, which is essentially doing some data analysis, creating business intelligence dashboards, automating things, maintaining around data infrastructure. We're also in charge of open data initiatives and various data governance things. We also, one important thing that I want to specify here is that we also have other colleagues, so to say. They're the consultants, obviously. As you know, the public sector procures a lot of things, but we have a little different approach in this regard, which is quite unique, at least in Latvia in public sector, because that we essentially, instead of procuring data analytics services from private sector by essentially procuring them to do something, we are essentially procuring body leasing additional team members to our team, which are like consultants that help us do. And this essentially allows us to maintain full control, full ownership, and organizational knowledge about everything that we do here. And this is quite an important aspect here because data is all about knowledge, and and what you have, and it's very important to maintain and keep this data inside your organization and not allow it to, go outside and die somewhere in a painful death. And this also, another benefits is that it allows us to be agile. This is one of our main building blocks, is that we have to be agile because there's a lot of data needs, and if you break them down in smaller pieces and build your data solutions iteratively in an agile fashion, it essentially allows you to give the fullest business value to your end users. And it also, in our experience, it very much reduces costs. Because as you know, consultants are pretty expensive. And this essentially brings us to our digital twin strategy. For us in Riga, digital twin strategy or digital twins are basically a natural extension of data analytics. That's what it is. And to showcase how this essentially works is I have essentially shown you there is this graph. This is our data team right there. These are all of the departments to whom we give data analytics services. In each department, it very much depends, but there are some departments who are very more technical than others. So many departments have their own analysts or specialists who are actually very much capable of doing data-related tasks. And then we have on the y-axis, we have data analytics maturity level. So this is something that when we first came here, there was full anarchy. And as you know, full anarchy in public sector means there's a lot of Excel files everywhere. And this is something that we want to prevent and to sort of build the building blocks to have a great data analytics capacity in our municipality. And so how does this look? Essentially, we as a data team, we are essentially providing continuously various data analytics services that I mentioned previously, which include, data analysis, BI development, data automation, various AI type of projects and that kind of stuff. And we are helping the departments and their analysts to navigate this very complex data field. And this is essentially how we let them, how we allow them to basically level up their data analytics maturity level to a better height. And this is how we essentially also start to, by basically working with each department, with the business stakeholders, we basically develop more and more mature data solutions, which eventually turn into digital twins and various levels of those data solutions. So this is how it basically looks. Don't forget about maintenance. One of the important aspects why we have an internal data analytics team is because various data solutions, including digital twins, they are very costly to maintain. As you know, data changes all the time. Someone can change the source system data, or a process changes, or a new law gets passed, and the data changes and it gets corrupted, so you have to always maintain those kind of services. So the more digital twins, the more digital solutions and data solutions you have, the more maintenance you'll be doing. So keep that in mind. And this basically brings us, as I have already kind of shown in the previous slide regarding the digital twins, those maturity levels, this basically brings us to our understanding of digital twins and the terminology here, which is very similar to what you showed here previously, which is very funny. So I guess we're at least moving in a similar direction here. So at least for us, there are 3 levels in Riga City Municipality that we're evaluating, essentially. We have the first level, which is a regular digital model. Then we have the digital shadow and obviously the digital twin. But the difference between them, or at least the way how we try to arbitrarily, divide these three things up is between the level of automation, between the physical and digital object. And as Markus already told, it doesn't have to be necessarily a physical object. In our case, actually in our experience, it rarely is a physical object. It's mostly a process or some other aspect inside the municipality that we are analyzing and that we essentially turn into a sort of model. And so for us, essentially the digital model, which is without the automated data exchange, the complexity level is very low, and it only increases as you go further along. For example, for digital shadows, we have this automated real-time data exchange. I guess you can also argue if it is real-time or in batch, but this is just a way how to think about it. It doesn't have to be a rule. And then we have digital twins, which in our mind is more complex solutions, which also involve data. Essentially, instead of data going from the physical object back to the digital object, it's also data going in the opposite direction. At this point, you're essentially giving the control to the machine. There is as little human input as possible in this stage. And this is essentially how it looks for us. Right, in the first level, digital models, they're pretty easy. We probably have these already. There's a lot of them in the municipality already. It's usually done in Excel, right? So someone downloads some kind of data, creates some nice models, and then presents them to someone, right? And for digital shadows, we invest heavily in business intelligence, and this is where we essentially start to integrate various data together. Where we have data warehouse and data infrastructure and Power BI reports and that kind of stuff. And for digital twins, it's a whole different beast. I have put here pretty pictures, but in our experience, digital twins, at least from my experience in finance and marketing, where we have developed something similar to digital twins, they usually don't even have visualizations. They are just a logic inside a server somewhere running and doing some processing data, essentially. So it's hard to sometimes even visualize proper digital twins. And then we go back to essentially what I showed previously with the way how our digital twin development roadmap essentially looks like, right? So as you remember previously, I showed you that we invest in each of the city department, we invest resources or data analysts and data specialists' time and money. And essentially we go through all of these steps in order to get to the digital twin, which is the holy grail of this whole thing. So essentially this starts very simply by digitalization, right? For any kind of advanced data analytics project, you need good data. As you know, the famous saying, garbage in, garbage out, right? So one of the first things you have to do is essentially simplify a lot of the processes, which are usually done manually in the public sector. And you have to digitize them and make sure that the data is available in a timely manner and in a qualitative format. Then we essentially do the integration, which in our experience in Riga at least takes a lot of time, because I don't know how it is here, but in Riga City Council, data is scattered around various institutions. So the transportation department might have their mobility sensors, or the energy agency has data about communal usage and electricity and that kind of stuff. And so you have to go to each one of them and actually integrate the systems together in one single point. And this is essentially the next step, is getting all the data together, because otherwise, what's the point? And at this point, when you already do this, this is when you essentially can create some kind of digital model, because you finally have the data in front of you. You can export it and actually do something with it and start to kind of make better decisions. And then the next big step is essentially automating this process. so that there's as little human input as possible in these steps. We try to automate the data pipelines so that the data from various systems gets automatically pushed up to the data models, and essentially this is how we get digital shadow. So at this point, if you are, for example, a mayor, you can go online to, for example, Power BI, open it up and see what's happening in your city in real time. And this is one of the first points where we are actually delivering real value to our end users. And this is where we also get visibility, which is one of the important aspects of building a digital twin. Because to get to this stage, as you can see, we have to go through 2 more stages. And one of the reasons for that is that we have to, in order to get to the digital twin, and so it is a meaningful solution that actually gives value to the business, you have to actually understand the underlying problem that you're trying to solve. And this is where where grasping the complex problem comes into the play. And this is why it's not only necessary to have some fancy graphs and data, it's also very important to, at some stage, to start analyzing the data and understand why, when you do something, what happens afterwards. So you're essentially doing data analytics and understanding the effects. So when something happens, what is going to be the result, and why. If, for example, you pass a new policy, why does the KPI go up or go down, essentially? And then we go, and after we sort of understand the effects and have a good understanding, and we have looked at these dashboards and digital shadow for several years, that's when we start to understand why things happen and what's the current data. Then we can slowly move to the next stage, which is we can actually start to prepare for a future. We can engage some advanced analytics and essentially simulate future scenarios, because previously we have accumulated a lot of data, we have accumulated the knowledge, we have analyzed everything, and we now understand the effects, and we can sort of start to predict the future and know that if we do this, or if we, for example, close down this street, it's going to cause a traffic increase in the neighboring streets, and we know by exact measure apparent how it changes. And so this is essentially the next step. And then for the final step in the digital twin, at least depending on our definition, this is where we essentially take the human out of the system, and we let we leave the control back to the system. And this is where we bring in the fancy tools like AI, where they can start to pretty much manage this themselves and basically make decisions for humans. But here comes the big question, and this is something that we are very much pondering in Riga as well, and I think we have touched upon this in the beginning introduction slides. Do we really actually need all of this? As you previously saw, we have like that y-axis is essentially the return on investment, or the value that these solutions provide to the municipality. And as you can see in the previous slide, it always goes up, but in reality, it's not as simple, right? One of the first things we very quickly realize is there's probably diminishing returns. So in our experience, when someone from the business department, for example, in transportation, speaks about digital twins, they very often actually mean digital shadows, and the further you go, actually the value sort of gets smaller and smaller. And then we have the next big thing, which is the cost. So essentially have added additional y-axis here, which is the cost. And as you know, advanced analytics projects, they're very expensive. They take a lot of time. Often they take several years to develop, because you have to build this understanding, you have to do the analysis, and it's a very time-consuming process, which involves a lot of IT and data specialists, which cost a lot of money. So the question is whether it is necessary to go this far to the digital twins. And this is one of the reasons why we are doing this sort of iteratively inside Riga City Municipality, so that we can have this cost-benefit analysis. So yeah. So essentially the point is perhaps we should stop here and not go further if it doesn't make any sense to do this. However, what I must say here is that this calculation, it changes. It's not fixed. It's dynamic. So what we see is, for example, this year, transportation department decides to be here, and it's fine. It's enough for them. But for example, 2 or 3 years later, they understand the problem, the data better. They have generated new ideas. They have explored the data, have done some data analysis, and now this essentially this benefit curve, it shifts upwards. So perhaps now it makes sense to actually invest in digital twin. So this is the main point that we're trying to convey here, is that what's important, at least in Riga for us, is to have this iterative development so that we can move step by step and not essentially make rash decisions and invest several millions in something that we don't yet understand and maybe don't need. So quickly, some examples or about some projects that we are thinking about. Some of them are in development, some of them have not even been started, but are sort of lying in our huge backlog of tasks that we have to do. So there's obviously a lot of potential for digital twins in mobility. A lot of like transportation and mobility planning. This involves a lot of sensors, a lot of IoT devices, a lot of cameras, recognition, AI recognition, that kind of stuff. And here are basically digital twin ideas are to have like green light corridors for example, public transport, or various traffic violation detection and variable public transport prices and that kind of stuff. Another one is in transportation. This is another thing where we have started to work on, is predictive road infrastructure maintenance. So, for example, this is on a yearly basis, or traffic department goes around and scans the roads with a camera, and then there's an AI model which essentially classifies the street based on the quality, what is the road surface condition, and we can use that to essentially manage or the maintenance process easier. Another big one is energy. For example, as you know, due to the war and this geopolitical situation, our energy expenditures increased by more than 60 million. So if we can somehow make this 1% better, we are already saving a lot of money. So various tools and how we can collect data and manage it backwards to basically make smart thermostats in our municipality real estate. And then we have obviously a lot of 3D models and geospatial digital twin ideas that we're also pursuing. So, in summary, or essentially what I want to tell all of you, the main point is that digital twins cannot be built in a single day. So, for us, essentially, we imagine building them like building a pyramid. You have to have good foundations, and you have to increase the data analytics maturity level. So you have to have good processes. So you have to fix a lot of the business stuff. This is, as some already said, you have to engage the business stakeholders, because without them we cannot do anything here. Then we have to make sure that there's good data availability and the data has good quality. This is one of the big problems, especially in public sector, because you're usually dealing with old legacy IT systems and lots of Excel files that you have to digitize. So a lot of time is to create a digital twin. A lot of time is spent on actually, creating various tools for the business stakeholders so they can input the data and actually work with it. And then obviously the next big step is understanding the facts, which is doing data analysis, understanding the underlying problem. So because without that, good luck. So, and for us, then the big thing is that digital twins are essentially a big part of our data analytics strategy. They are sort of the end goal, and in our way, essentially they are eventually built by essentially consistently solving business stakeholder problems, by essentially providing these data analytics services to our various city departments, by iteratively essentially solving their problems, we eventually get to this maturity level where we can say that this is finally a digital twin. And then one big aspect here is that digital twins, by the definition, they're very complex solutions. So it's always easier to break them down in 100 smaller pieces and do them separately, one by one, while still providing value to the business stakeholder. And if at some point you realize it doesn't provide the value anymore, you can stop. That's a very important thing, that you don't waste too much taxpayer money on something that you don't even need. And then what's been paramount for Riga City is that it's very important for us to have this internal data analytics expertise, that we have this data analytics team, which consists of technical data specialists, which can actually maintain the full control and knowledge base of this. This was one of the big problems when we first came here to try to solve in Riga City municipality, is because there was nobody. There was pure chaos, so every department had their own sort of data and digital strategy. And this is one of the first things that we tried to fix. And this also allows us to essentially keep the knowledge going forward, right? If you only have consultants or you don't have this internal expertise, the data and the knowledge is going to be lost, and that's not something you want to. And that's something you want to prevent, because after all, you have paid for it a very big amount of money. The next big thing is why internal data expertise is because you want to be as close as possible to the business, to the end users. So if you are very far away, or if you're a consultant, and you probably don't care about the business that much. And then it's important that there is someone in your organization who is talking with the business and understands all the organizational data needs. So one of the first things that we did when we started was conduct a serious big audit and go talk to each of the departments and understand their data needs. And we came up with more than 300 projects. Because the departments, they really need this, and now we have someone in the internal side who can basically take this together and start working on it. And yeah, internal expertise obviously makes sure that there is also a purpose, and it prevents cost overruns, at least in our experiences, because we can prevent cases where the business says that they actually need a digital twin, but in reality they just need a digital shadow or a regular Power BI report. Then obviously the big one is the long-term maintenance, because at the end of the day, after developing all these data tools, you have to have someone who understands them, who has knowledge about them, and who can maintain them and knows what to do when something goes wrong or it starts spewing out wrong data. So that's it. Thank you very much.